It's Christera here, doing my Science 215 presentation, and I chose to do a KWL chart. So this is what I know. I know that the Saskatchewan curriculum has a lot to do with the scientific inquiry of student learning, the scientific literacy, the STEM or STEAM, UBD outcome-based templates for units, First Nation, Métis, and Inuit teaching strategies and concepts. I learned the FIVEE models, the assessment in science, and holistic versus reductionist. So with this chart, this is my summary of learning. That's what I already know. And now I'm going on to what I want to know. This is a picture of me, and in my brain I want to know, number one, how can I use scientific inquiry in my teaching? 2, how to engage scientific literacy. 3, how to use STEM or STEAM. 4, how to make a UBD outcome-based unit. 5, how to use First Nation, Métis, and Inuit concept in my teaching or in my classroom. How to use the FIVEE model as my teaching strategy. Oh, that was number 6. Number 7 is what kind of assessments are needed in science. Number 8, the differences between holistic versus reductionist perspectives in science and how to incorporate these teachings. That is what I want to learn. So now I'm going to go on to what I learned. So for number 1, what I learned for scientific inquiry is that it's student-based. It's the students' peak of interest in science. It's their way of asking questions about certain topics in science. It goes along with the STEAM teaching strategy, the STSE, which is the science, technology, social, and environment. It focuses on the historical aspects and the relationships between science and technology. And what I learned about this scientific inquiry is that it has to do a lot with, I've noticed with First Nation content, and that before European contact, First Nation people, that's how they talked. They talked using scientific inquiry, I guess, basically the relationship between a person and the land. But with today's society, it's the relationship with science and technology, which is kind of the same thing because our brains are kind of like that technology that we have, where we can just continually learn and technology is continually improving. So I found that very interesting and how I made that connection. That's just like what I want to talk about. And for the scientific literacy, it's just for what I got out of that is that it builds knowledge, student skills, like how to become I guess better in the world. It builds their knowledge on the topics discussed in science class. I know that there's 4 foundations to scientific literacy. Foundation 1 is science, technology, society, and environment, which is the STSE. And it helps students understand the scope and character of science. Foundation 2 is the scientific knowledge, which is the subject matter of like life science, physical science, earth and space science, traditional knowledge, indigenous knowledge, scientific knowledge, and like fundamental ideas. And I find that to be very important because it helps us to build like good citizens in our communities. It helps students problem solve the things that they need to do. That is scientific. Everything is science, I think. Foundation 3 is the scientific and technological skills that initiate planning and developing, creating ideas and plans. This is where they begin to use these problem-solving skills so that they can better achieve themselves in the world and in the classroom, and just be able to fix their mistakes. It's basically trial and error. Foundation 4 is the attitudes of science. That's where they begin to enjoy scientific inquiry, where they begin to like feel at peace with science, I guess, like be able to learn it more easily, where they appreciate it, and where they ask more questions, and they learn the collaboration of science with one another, and like teamwork skills and how to be safe while experimenting. So that's what I found interesting about the scientific literacy part, and I think that's very important as well. Like this whole curriculum is really interesting, and it all focuses on like the First Nation teachings, and I'm starting to understand these concepts between how to incorporate First Nation content into our teachings. And it doesn't literally have to mean where we have the sweetgrass and things like that. It's just like the way we teach. It's basically trial and error. And that's what science is anyways. So for number 3 is how can I use STEAM in my classroom? And STEAM is science, technology, engineering, arts, and math. And it focuses on preparing and inspiring generations and student learners to meet challenges of global society through collaboration, problem solving. It prepares students for post-secondary education purposes, even for the workplace. I guess it's like common sense. Yeah. And using the engineering, arts, and math, like these are all cross-curricular competencies where teachers can use this sort of teaching style to help students get out there instead of just sitting in the classroom, where they have more hands-on. And I think it's more important for them that they learn in this way, where they can begin to ask questions, or they begin to problem solve, or they begin to create and plan their own experiments, because like that's what a lot of children need, is that extra push. So going on to number 5 is how to use First Nation, Métis, and Inuit concepts in my classroom. Is just basically doing the teachings from the past, where we just tell them what we ask of them, and then they begin to share and give their thoughts using a dialogical learning technique, where they can be able to present, ask questions about science. The talking circles are dialogical teachings, and that was one of the main important ways that the First Nation people or Aboriginal people learned, and I believe that that's what everybody needs to use, I guess. Well, not to only put Aboriginal teachings out there, but just to use them all together, that we can all come together and be able to learn and extend our knowledge and technology together instead of just having it one race. So I think that's a very unique way to learn, and I find that children do learn easier or quicker that way, where if they make a mistake they can go and fix it instead of having somebody do it for them, or always getting like wrong answers and then not being able to correct them. I believe that the problem solving comes from trial and error, like I said before. So how for number 6, it's the 5E model teaching strategy, where I'm going to engage my students on inquiring about science. I'm going to have students ask what they want to learn that relates to these 4 different outcomes in the curriculum. And then we will go from there. I will have discussions where students will be more engaged, because then they're interacting with each other, and not only to me but with each other as a whole class, and I believe that's very important and very strong for them. How we're going to explore it is, well, we can have what is that called? We can have field trips. Not all the time, but I think a field trip is good for any grade. They need to be able to explore and have hands-on activities. It can't only be textbook, it has to be where they can actually do something. That's what I plan to do for my class. And then I will explain to them what their roles are. I think group work is very important in science. A lot of ideas come from different people, and I think that's what works best is teamwork. How we can extend it is they keep on doing it. They just keep asking questions. They keep working together. They understand the safety precautions of science experiments, and things like that. So, and how they will evaluate is where I would have students evaluate each other in their groups, and they will be able to learn from each other. For the assessments needed in science, I think it all has to do with like student achievement of the curriculum, and like the effectiveness of teaching strategies employed, student self-reflection on learning. So there's 3 different types of assessments that is in the curriculum, where there's assessment for learning, which occurs throughout teaching, and it's teacher driven, where to me the First Nation teachings, it was our elders that taught. They were the ones who had the knowledge. So that's where teachers come in. We're like the elders. We're giving that knowledge off, and that's very important. So the second one is assessment as learning, where it's student reflection, and they monitor their own progress, and that's where they begin to do trial and error from the elder teacher teachings. So that's their assessment on themselves and how they can correct their wrongs. The assessment of learning, I think that's it. It involves the teacher's use of evidence of student learning, which is usually at the end of the subject matter. And that's just like I guess, being done. Like, I don't know how to explain it. Fulfilling your achievement, completing your goals, and that's what a lot of students need to do. Teachers and students need to focus on goals with each other, and for us, we need to teach them the outcomes, and they need to learn those outcomes. And I think the I can statements are very important with this, because then it teaches students that they can do it and that they shouldn't give up. Yeah. For number 8, the differences between holistic versus reductionist in science. For this part, I found that these two go together. Like, I don't think they should verse each other. The holistic is basically like the relationship between organisms and environments, and that's like the same thing with scientific theory and the technology. Like, if we were to talk about science and technology put together, think of science as the world, the land, and technology is us, the humans. We go together, it just goes together, you know, like, the only difference is that science and technology is, or the reductionist is that they don't give back to the land. But it's basically the same thing, you know. And that's just what I wanted to share about my whole experience in this educational science course. I learned a lot about teaching science, and that's my presentation. And I'm like, thanks.